Wow.
That's
fine.
So finding
It's like 4
max,
Finding
finding max volume. Here you go.
Alright, let's find some max
A
volume.
manufacturer wants to design an open box having a square base and surface area of 108 square inches. What dimensions will produce a box with maximum volume?
So if you have a square base, is it also like the sides to be square too?
Yeah. Well, not necessarily the base has to be a square, but the sides don't have to go up as
So
well.
length times the width have to be the same.
So, I'm terrible at drawing 3D stuff here.
Gabe's perfect. I'll come up with it.
I'll draw it for you.
Whoa, that is a rectangular curve.
That actually isn't so bad.
Hey, you like twisting stuff. What the heck?
That was bad. There we go. So there is a box. The top's open, so it has no top. You can place things in it.
So when it says the surface area is 108 inches square, is that just the outside of the 5 sides?
Yeah.
Does it include the top that's not there? Does it include the inside?
So let's label what has been given to us. It says that it's got to have a square base. That means this has to be x and that has to be x. They both have to have the same dimension, the length and the width here. But all it says is the base is square. It doesn't say the sides have to be square. So the height doesn't have to necessarily be the same dimension as the length and width. Okay?
X squared times h.
Well, it may turn out that it's going to be x. We don't know. Okay? How would you find the volume of this?
X squared times h.
X squared times h. So you need to make a note right here. This is called the primary equation because this is the quantity to be optimized. Didn't they want us to optimize the volume? Didn't they say we want to find a max volume? And isn't this the formula for the volume? So this describes the quantity to be optimized. Okay. The problem is, you guys listening carefully? It's kind of a big problem. We can't use calculus to maximize this yet because we have a function with 2 unknowns. We have x squared, which we don't know, and we have h, which we don't know. You can't deal with in a function if it has 2 unknowns. Okay? And I know you've done stuff like this before, tons. Okay? What we need to create is find a secondary equation that relates the variables in a different way. We have an equation that relates it in terms of its volume. But we already have that. We want to find out another secondary equation that relates the variables together using the given information, and it's going to be
Surface area.
it's going to be surface area. If we can create an equation for the surface area, that's going to be a secondary equation. Now, just to give you a little preview of what's going to happen here. You listening? We're going to create a secondary equation that has x's and h's in it. Right? If we can solve that secondary equation for h, like h equals blah, 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 what can we do with that? We can plug that in for this h, and then we have a volume equation which is x and no h's. And if it just has x's, we can take the derivative, find the maximum. That'll give us the maximum volume. You guys see where we're going with this? Right? So,
Oh, that'd be so cool.
now we assume that by surface area they mean just the area of the outside of the box. Okay? So how many faces are there of the box? How many faces?
6 faces. 5.
There's only 5 because there's no top. Okay, so
Alright.
now this one right here, what's the area of that? You guys with me here? The surface area of that, so I'm going to say SA for surface area. Surface area equals x squared because that's the area of the base. And then, I need a different color here. What would be the area of each of these sides here?
X times H. So there's 4 of those, so 4xh.
The area of those sides are xh, and there's 4 of them. So we're going to add to x squared, we're going to add 4xh.
Yes.
Okay, and those are the area of all 4 sides.
Surface area is 108.
Ooh.
Because to find the area of a rectangle, you need length times height. Does that make sense? So the area of this right here would be x times h. But then the area of the one behind it would also be x times h, and there's 4 of those. Okay. But don't we also know the surface area?
Yeah, we do.
The surface area is 108. Yeah. That's the area of the base of this box because it has a length and a width of x. X times x is x squared. So now we got to solve this for h. Solve for h. So it's going to be 108 minus x squared all over 4x. I know we're kind of doing a lot of steps combined, but you okay with that?
Yeah, we're okay with it.
H is equal to 108 minus x squared all over 4x. Now plug that into the volume formula. Volume equals x squared multiplied by 108 minus x squared all over 4x.
Would it be better to combine that, or would they do them separate?
We could probably simplify this down a bit. Now, again, this is kind of doing some steps, just for sake of time, doing some steps combined. You guys with me here for a second?
Yep.
What about this right here, canceling that with one of those?
Yeah.
Is that okay?
Yeah, that's cool.
Then you just got 108x minus.
Okay, I canceled this x right here with one of those x's, right?
Yeah.
Now you can distribute the x, and it's going to be 108x minus x to the third all over 4. Okay. Now I would actually do one more thing here. 108 divides by 4 evenly.
Does it?
Yeah.
It's 27. So because of that, I would probably write it like this.
It's crazy.
Negative x to the third over 4 plus 27x. Just because it would be easier to take a derivative in this form. For me at least. Let me ask you, would you rather take a derivative of this that I'm circling or a derivative of this that I'm circling?
This. That.
I would rather take a derivative of this.
I just say this.
The question will have to be.
Right now it's 30 seconds.
Not unless it has variables in it. I suppose you could,
Then
but
how would
Kind of running out of room at the bottom.
does that change zero?
it would just turn into 0. So yeah, I suppose you still could. It would just turn into 0.
In this corner. And in this corner, trying to solve it. It's getting difficult.
So I can take this over here. Negative x to the third over 4 plus 27x. That's our new volume function.
You don't have to turn it back. Small.
Yeah. Now what? Okay, guys, hold on. What are we trying to find? A maximum volume. So this graph right here, okay, it's a cubic. It's negative x to the third over 4 plus 27x. So it's a cubic function, you know, looks something like this. So it has relative extrema possibly. We've got to figure out which one. A max. We want a max, right?
We need to find max.
Okay.
And how much?
So let's take the derivative.
Right now it's all.
What's it going to be?
Whoa. Negative 3x squared.
Fractions is what gets you a time when it turns when it turns 4 to 0.
Think about it this way then, you guys. If the dividing by 4 is bothering you, what about this?
Oh, hey!
Does that make more sense?
Negative 3/4 x squared.
Take the derivative.
Thanks, Mr.
Okay, these two things are equivalent to each other. Okay, so that might make it easier to visualize in your head what the derivative. Don't you just drop down 3, reduce the exponent?
Yeah.
So it's going to be negative 3x squared over 4 plus
27.
27.
And now,
Now we set it equal to 0 because if it's an extreme, that's where the first derivative equals 0. So we take this and set it equal to 0. And we can solve this, yes?
yeah, so
Yeah.
first you want to subtract 27.
Then we're going to multiply by 4.
Then you divide by negative 3.
And then we're going to square root of that.
It's going to be a plus
Okay,
one.
again, for sake of time, you guys, just kind of doing some steps in our head. If you subtract 27 and then multiply by 4, that's negative 108. And then you divide by negative 3. So negative 108 divided by negative 3. So we have 36 equals x squared.
Plus or minus 6.
Now, technically speaking, x does equal plus or minus 6, but you have to think that this is a problem in terms of real-world context. X is a distance.
You can't have a negative distance.
You can't have a negative distance.
Unless you zoom.
So the only feasible solution is x equals 6. Okay? Now what do we do? How do we know that this is even a maximum? You guys understand? This might be a relative minimum. I don't know.
Put it on a number language. That's the points around it.
It wouldn't be a bad idea just to verify that this actually is a maximum, a relative maximum.
Stupid Bill. That's what it comes to this bit. Stupid. That's what a nice guy is. This guy. That's it.
Okay, and go back up to here and test it. You guys do it quick.
Yeah, we will.
Got to plug in 0.
Well, you just, yeah, possibly.
So that's a positive on the left side.
Okay, how do we know for sure? What kind of a sign do we get over here? Plus or minus? It's increasing and then it's
Decreasing.
decreasing. It's increasing and decreasing. So yeah, that represents a maximum volume. So you guys, we're not quite out of the woods yet. We know that this has a dimension of 6 and that has a dimension of 6, but what about the height? We need to know all the dimensions that maximize the volume.
Well, I would plug those into the surface area equation.
Close.
Plug those into the surface area.
Yeah.
Let's see. Not that what H was, I'm introducing like an X, and it gives us H.
Okay, so try it. We need to know what H is.
Alright, what is 108 minus 36?
We need to know what H is, you guys. Come on, let's go.
6 divided by, what's 4 times 24? 3. H is 3. You got 36 times 3. 108, and that's the same as the surface area. May do this one.
You guys follow?
Yep.
You plug in a 6. Solve for H.
Who has it?
You can't just rely on somebody else to do the work for you. You've got to be able to solve this comfortably. If x equals 6,
36.
108 minus 36,
36.
108 minus
72.
72.
72 divided by
24.
24 is
3.
3. It's not that hard to do. So h equals 3. So those are the dimensions. We have 6 by 6 by
3.
3. 6 by 6 by 3. That would yield maximum volume.
Okay.
Okay? So we're going to do a few more examples next time, but you guys, I need your attention for a second.
Yeah.
We went through some steps here that you need to understand. First of all, we had a primary equation. But the problem with the primary equation, it had too many unknowns. It had x and y. Or it had x and h, rather. So how did we get around that?
You have a secondary equation.
We had a secondary equation with the same two variables. We rearranged the secondary equation, plugged it back into their primary equation, right? Then what did we do?
Took the derivative of that.
Took a derivative and found a minimum, or in other cases it might be a maximum or minimum. That's how you do these. Primary equation, then you make a secondary equation, rearrange it, plug it into the primary equation, take a derivative, and optimize it, pretty much. Okay? We'll do more examples next time. They're not that bad, are they?
No, they're fun.
We love them, Mr.
I just want to see sand falling into a conical box.
I'm still recording. I'm still recording.
Brandon's the worst.
Keep going.
Oh,
Ready? Okay.
Happy
Happy birthday, man.
But she's a jolly good fellow. But she's a jolly good fellow. But she's a jolly good fellow. Who's jolly and